All right, so angles and angle measurement. So angles and standard position. So if you're, how many of you guys are in chemistry right now? Okay, have you heard of STP, standard temperature pressure? Yeah. So standard temperature and pressure, people are like, okay, so at this temperature, so you are at like 0 degrees Celsius at 0 degree altitude with 1 atmosphere of pressure, right? So that's like, that is the standard. The standard for left and right, I mean, we all said, okay, this is the left, this is the right. We set a standard. Fun fact, the weight that a kilogram is based off of is in, I think, like London. Yes?
Do you have an extra copy?
I do not. So you have to take notes the old-fashioned way. So the standard kilogram, everything is based off of that. Like there's 1, and like it's all the same size after that. So standard means this is the way we do it. Every single time it will be this way if we're in standard position. So as a student, what is your standard like sitting? It should be good posture, not head down, not elbows, right? So standard is when, here standard position is when the vertex is at the origin. So remember vertex, if you have 2 rays, you have a point, a ray, shared endpoint, and a ray. This is the vertex. The vertex are where your 2 endpoints of the rays meet. The initial side is the positive x-axis. Okay, so we're talking about angles, standard position. So the initial side is the positive x-axis. So this is the positive x-axis. Every single time we're going to have our starting point right there. We're going to have our starting ray there. And then we're going to have our terminal ray rotate about the vertex a certain number of degrees. So initial side is where you start. Terminal is kind of like a bus terminal, a train terminal. It's where you end. A little morbid, but if you have like terminal cancer, I mean, that's where you end. Terminal is the end. Whatever.
Yeah.
I'm sorry, you'll never forget it. There you go. Terminal is where you end, not where you start. It's where you end. The terminal side is obtained by rotating about its initial side. Okay, cool. So let's talk about some angles. So you see here I have 0 degrees, and if I rotate 1/4 of the way around, I'm at 90. Halfway around is going to be 180, and then if I go 3/4 of the way around, I'm at 270. What happens if I rotate all the way around, a complete circle? I'm at 360. Okay, so we know that this is, 360 over here. Okay, so let's practice a couple times. Let's practice making a angle, but first, let's talk about positive versus negative angle measures. So a positive angle measure results from the counterclockwise rotation of the terminal side, meaning it starts the initial and it goes counterclockwise, versus a negative angle is from clockwise rotation. So it would start at the initial side and it would go clockwise around. That would be a negative angle. So angle measures, if the measure of the angle is positive, the terminal side has been rotated counterclockwise. Otherwise, if it's a negative angle, it's been rotated clockwise. So we're going to practice drawing these angles. First is 210 degrees. So we're going to draw them in standard position. So the first step is to draw our initial side. Our initial side goes on the positive x-axis. So it's right here. So this is my initial side. You could. If you have like any colored markers, that might help you, so have to be careful not to make a mistake. So that's my initial side. Where would 210 degrees be? So let's see. So remember that this is 90, this is 90 up here, this is 180, 270, and this is 0, or you can say 360. Alright, so when I'm drawing my terminal side, let's see, if I go, here's 90, 180, 210 will be between 180 and 270. So the terminal side will be somewhere over here. So you don't need a protractor necessarily, you just need to have it in the right quadrant. So I know 210 degrees, let's see, 210 degrees is 60 less than 270. All right, 60 less than 270, and 180, it's 30 degrees more than 180. So it should be a little closer to 180 if I would draw it more precisely. So maybe like a third of the way there. That's a little bit closer. And then I draw my rotation. And with an arrow, so I'm showing it's going counterclockwise. It's a positive angle, yes?
Can you possibly describe how you find the terminal side?
Yes, so 210 degrees, I knew I had to go past 90. I go past 180, and then I'm between 180 and 270.
Find where you started.
I always start standard position,
Which is just the right.
which is the positive x-axis. That's where I start every time. All right, let's go on to the next example. So negative 40 degrees. Where would this be?
You go counterclockwise.
I go clockwise because negative directions go this way, positive goes the opposite way. So negative 40.
Just go down a little.
I go down maybe about halfway. Halfway between 0 and negative 90 degrees. So if this is 0, this would be negative 90, negative 180, negative 270. And remember, we're going around this way would be negative. Okay, so if I would go halfway, it would be 45 degrees, negative 45 degrees, but I only want negative 40. So, it's close to halfway, it's fine. So then I draw my arrow from my initial to my terminal. So this is negative 40 degrees. I should have labeled the other one, sorry. 210 degrees. Negative 40 degrees. So negative goes clockwise. Just like a clock, here's 12, 6 clocks go that way. Negative angles go clockwise. Do not despair. We have.
Draw it within the angle instead of outside like the circle.
So, right. So I'm drawing it inside the angle. Same way I drew it inside the angle with part A.
When you draw it.
I drew it inside the angle because 210 degrees is an obtuse angle.
Is it just saying like where it is on the?
So it's telling me which way I'm going, because if I had this one in particular, I have two options. Either I went this way, or I could have went all the way around this way. And so I'm trying to say if this is a positive or a negative angle. I'm trying to distinguish between the two ways I can go from my initial to my terminal. So you see how I can go positive this direction, or could have just went negative that way. So by having the arrow, it's showing you if it's a positive or negative angle.
Yeah, I don't know.
What was your question?
I don't know if I'm gonna be able to like
Articulate it?
articulate it. Yeah.
That's fine. We'll do another example and we'll see if it pops up. All right, so 470. Here's my initial side. Here's my initial ray. Where will my terminal be?
A little bit.
No, it'd be
It
up.
goes all the way
So
around.
what would happen? Right, so this would be a 360.
And then it just go to.
It would
And
still
then
come
it
left.
goes another.
It would just be at the y-axis.
110 degrees, it
It
goes
goes a little bit past the y-axis.
a little past. Because remember, this is 0, 90 degrees, 180, 270, blah, blah, blah. So what I just did, someone's like, oh, it goes all the way around, because 470 is more than 360. So not only does it go all the way around, it's going to go past 90 to like 110, which is right over there. So normally the way I do it is I draw my initial, and then I like start drawing where my angle will be. I'm like, okay, 110 is about right there, and now I'll draw my terminal side. That looks about right, because it should be closer to the 90 than 180. 110 is closer to 90 than it is 180. So this is the kind of number sense I want you to be comfortable with. Is 110 degrees closer to 180 or closer to 90? So it's 20 degrees from 90 versus 70 from 180. So it should be closer to 90 degrees. Awesome. Questions so far? Yes?
I saw you've been doing, like, if you go back to the B, you've been labeling, like, there you put negative 40, so let's just say, like, C is 470. How would, do you, like, need to label it?
You don't have to,
Okay.
but I'm trying to be as clear as possible with you guys.
Okay.
Because it's actually telling us, draw this. If I had more than one angle, I would definitely have to label and distinguish between the two. Yes, Tessa?
So you're talking about like the angle like in the thing, right?
Yep, the angle that is traced out between my initial and final. It's
So
the angle
where
between them.
The number, like, how you get to that little angle in between the two rays is just the number where it will lay on that chart. That's just how you find the other ray, right?
Yeah, that's how I find where my terminal will be.
Okay.
All right, let's try D. 185. Okay, so I know that this is 0, 90 degrees, 180, and 270. Which quadrant will this lie in?
The third.
The third quadrant. Okay, so now we have to figure out how close. Is it closer to 180 or closer to 270? How do we know?
120.
Because it's literally 185, so it's going to be super close to 180. And then I'm going to trace out from my initial to my terminal ray. So that is 185 degrees. That's it. That's all you would have to draw. All right, let's try the next one. So 810 degrees. Oh my gosh. So I have my initial right here. My initial. So if I go around one time, that's 360. Yeah, if you guys are already done with this one, you can try the next. So 5s, this is 450. Is that right? Let's see, 7.
You go around 2.
8, 10, yep, so I go around 2 times, because at first I took away a whole turn. And now I'm at 450, so I have to go around again. So now I've gone around 2 times. So let's see, 450 minus 360. 90. And then I come back to 90. So I'll show you how I did that again. All right, so I go around once, I go around twice, and now that I've gone around twice, I go to the 90 degree. So that's my terminal. So I'll show you again.
Subtracted 360 as many times as you could.
Yep, until I reach a number that's between 0 and 360 to know where I am on my chart. All right, let's keep going. We're on G. Okay, so this is more than 360, so no, I'm going to go around at least one time. Minus 360. Yes, Jonah.
Wouldn't it be 120?
Where?
480 minus 360.
Where's 480? Did I mess up?
No.
No, that's 450.
Oh, that's a 5.
I'm thinking 8.
At the shop. Put in your eye drops.
Be nice. Be nice.
No. Completely blind. That's crazy.
Do you need to move up to the front?
No, that is bad.
Here's my initial. So I'm going to go all the way around once, and I'll end up at 30 degrees. So I go around once and end up at 30 degrees. 30 degrees is between 0 and 90. So that's where I put my terminal. Yes. Sure. Are we good to move on? Yep.
I'm just going to dictate it.
Did you find it, Maya? Okay. Yeah, I'll be a bathroom pass. I just don't want you working on homework when we're learning a lesson. Okay.
Is that 30 degrees?
Yes.
You don't have to rewrite it. I saw my glasses on it.
That's fine. All right. Let's try this one. All right, how do I do this one, Matt?
Well, you have to, you are going to go around once, so you try 360. What is it, 135? So you start from your origin.
Okay.
You have to go past 90, and it's going to be in between 90 and 100.
Good. Because 130 is between 90 degrees and 180 degrees. And we went around one time already. Perfect. Let's try the next one. Negative 50 degrees.
Wait, can you go back?
Yep. Negative 50 degrees. So here's my initial side. Where's my terminal side going to be?
On the right, but like more towards the y-axis.
Yeah. And it's negative, and so it's going clockwise since it's negative. All right, let's try the next one. So negative 420. How would I do this one?
Okay, well you're gonna, can
Here's my initial, right, Ari? Tell me how to do it.
I? So first, you're gonna go clockwise.
Good.
So then also you're gonna, no, yeah, okay.
If I go all the way around,
Once, and then you're gonna add 360. And then you're gonna go up, or down to 60 degrees.
Yep.
Negative 60 degrees, which is right there.
somewhere, I mean, that's a little bit more than 60, but it's fine.
Yeah, whatever.
Cool, so that's fine. So the big deal I want you to notice, the difference between H and J. Notice J is spiraling around clockwise. H is spiraling around counterclockwise. Positive angles versus negative angles, because you will have to draw these. You'll have to draw them correctly. All right, so let's try the next illustration. Draw the following angles in standard position on the same axis. Okay, so which one do you want to do first? Matt, which one do you want to do first? 40,
40
perfect.
first.
All right, here's my initial ray.
And then you just go up a bit.
And I just go up a little bit,
40.
and this is my 40 degrees.
Yeah, and then you're gonna.
And now if I do
360 now, it's gonna
400,
be in the same exact spot.
No, it's gonna be
three,
lower.
It's
oops,
gonna be in the same exact spot.
360 around, oh my god, it's in the exact same spot. What the heck? 400 minus 360. Wow. So check it out, check it out. These are in the exact same place. So they have the same initial ray, they have the same terminal rays. So if you think about the word co, right? Like co-curricular, co-ed, co-managers. What does co mean? Shared together. So if you have two co-terminal angles, co-terminal, that means they're going to be sharing the terminal side. Co-terminal angles are two or more angles in standard position, meaning their initial ray is along the positive x-axis, that share the same terminal side. They are co-terminal, meaning they have the same two rays. It's just the difference is, do you go around halfway? Do you go around once and then hit? Go around 50 times and then hit the same terminal ray? They all have the same end place. The difference is how many times they're going around the circle and the direction they're going. So these are three co-terminal angles. So first, notice that 60 degrees is I'm just starting from standard, going to my terminal, positive direction. Versus 420 degrees, I go all the way around once and then up to my terminal. Versus negative 300, I start at my initial and go to my terminal from the opposite direction that 60 went. They all have the same initial and terminal rays. All right, do we have questions so far?
Mostly no.
Would it be better to draw it with multiple colors?
If you have like two terminal rays, that's really it. It might be better, but I just worry about you guys making a mistake and you can erase. So, honesty. Just need to like practice a little bit. Okay, so how do we actually find coterminal angles? An angle that's coterminal with another one, meaning they share the initial ray, they share the terminal ray. Ones that hit the same spot, you can find them by adding or subtracting any multiple of 360 or 2 pi. So we know 360, angles, rad, we know how to do that. 2 pi, that's the second way you can do with angles. That's the second way you can deal with angles. 2 pi is radians. So remember how I've talked about make sure your calculator's in degree, DEG, instead of rad, RAD. So radians are the other angle measurement. And we're going to go through what that is. We're going to hit that before the end of class. But first, for each angle below, find one positive, one negative angle that's coterminal with the given angle. Okay, wait, so one positive, one negative, and how do I find coterminal angles? What do I do? How do I find them?
add 360.
You add or subtract 360.
Add or subtract 360 until I have it one positive and one negative. So the cool thing is, there's an infinite number of coterminal angles. Infinite. Do you want to add 360 like 10 times? Just keep adding it. Because that will have the same end place. Because every time you add 360, you just go around twice, go around 3 times, whatever. All right, so let's do 210. How do I find the positive coterminal angle?
And coterminal is like the one that
They-
was 40 and 400.
Yep, that's an example of a coterminal angle. Ones that have the same start and end. They have the same initial and terminal rays.
So all of the all of the ones here, like they're going to be coterminal, or
So on A, what I'm trying to do is find one positive and one negative angle. That's going to be coterminal with 210. So the way I'm going to do this is take 210 and add 360. And I'll find one angle that would have the same initial and terminal rays. So I add these. This is 570 degrees. And when I want to find a negative coterminal, I will subtract 360. When I subtract 360, I will get negative 150. So I found a positive angle that has the same terminal ray. And I found a negative angle that has the same terminal ray. Hey, okay. Let's try the next one. Ooh, negative 120. Okay, so first, if I want to find a positive coterminal, I'm going to add 360, 240. And if I want to find a negative, I'm going to subtract 360. So far, so good. For 510, if I want to find a positive coterminal angle, I'm going to, I could add 360. Technically, you're not wrong. I just want to make sure we're in the groove. So this is 940?
Yes. 940.
Yep. Okay, cool. You know, let's just do our thing. Let's subtract 360 from this.
So we're gonna get on.
So this is 220. Oh, wait, that's not negative. What the heck?
Subtract 7.
So I could have said, or 220 degrees up here. So when Arya was like, oh, subtract. Yeah, I mean, that's not wrong. If I subtracted, I still got positive, but I have to have a negative angle. So I need to subtract again. So I subtract 360 again, and I'll be left with negative 140. Cool. Yeah, that one works as well. But I have to have a positive one and a negative one. So this is a tricky trick because 580 is more than one time around. So by subtracting 360, I still had a positive angle. I had to subtract 360 again. All right, let's do part D. This is a tricky trick. Maybe you see what's going to happen. So take negative 800 and add 360. When I add this, what do I get?
Negative 540.
Negative 540?
440. Sorry. No, that's not wrong.
440. Okay, so wait. I could actually have that as my negative coterminal angle.
But,
And I need to add 360 again.
and then what happens?
Still have negative 80. Check it out. I found two coterminal negative angles. So I add 360 again. 280 degrees. All right, so I'll zoom out a little bit so we can see this.
So you can use either of those negatives?
Yeah.
Okay.
So that's the cool thing is when you guys are doing your homework, unless I'm like specified, like, oh, find, find all the coterminal angles between positive 1,000 and negative. Like, unless I specify, technically, there's two answers. There's infinite number. Because I could keep subtracting 360 and find lots more coterminal angles. Okay, are we ready 4 radians. All right.
Yes,
Okay.
Absolutely.
So a radian measure of angles. So we know all about degrees. I'll wait. All right, so let's sit up. Let's have our elbows off the table. Let's be attentive students. Thank you. All right, so sit up. You can do it. You're on power. Yeah, neck strength.
She went from
Don't let your elbow take all the strength. That should be on your neck. Okay. So, radian measure of angles. First off, what is radius? What's a radius mean?
Half of the circle.
Half the diameter.
Half the diameter. The diameter is the longest chord of a circle. So the radius is literally the distance from the exact center of your circle to the outside. That is not a rigorous definition. All right, Maya, put away your phone. So the radius is the distance from the middle to the outside. All right, so that's a radius. So 1 radian, right, the angle 1 radian is going to be an angle whose terminal side intersects an arc length with the same measure of that of the radius. Meaning, if I went and got a piece of string, right, I got a piece of string and I lay it across the radius and it's the exact length of the radius, take that string and wrap it around the circle. So, I take the length of string that I just laid on the radius and I wrap it around the circle.
You should get full circle.
Well, no, the radius, the one radius, the length it carves out is 1 radian. Okay, so that was not good English. Just a moment. So this is the initial side. Here's the terminal. So a radian, 1 radian. So this is 1 radian. Because the arc length, literally this length right here, the length of the circle is going to be the same length as the radius. Okay, so the terminal side intersects the arc whose length is 1 radius. That is 1 radian. In other words, radian, the angle radian is the arc length divided by radius. So hold on. So how do I actually label this? How can I compare that against degrees? That's our question. What if I wanted to know, what?
45 degrees?
No, 57. But you don't know that. So, okay. If I would go all the way around the circle, what is the arc length? If I go all the way around the circle, what's the length around a circle?
360.
That's the number of degrees. I want the length. I want
The
the,
radius times 2,
what's it called?
diameter.
Nope. I want the circumference. Thank God. The arc length, if I go all the way around a circle, literally, what is the distance going around a circle? It's a circumference. So, if I would go all the way around a circle, it's going to be 2 pi times r. That's the distance going around the circle once. That's the distance going around the circle once. That's the circumference. Now, if that's my arc length, and then I'm dividing by radius, what happens to the r? It goes away. So the number of radians it takes to go around a full circle is 2 pi. So this means 360 degrees is the same thing as 2 pi radians. Because radians, all radians is a ratio of how many radius lengths have I gone around the circle. So if I label my circle here, going all the way around is 2 pi. Also, this is the same place as 0. What about if I would go halfway around? What would the angle be if I went halfway around? It would be 180 degrees, but I want it in radians. So if going all the way around is 2 pi, going halfway around is, what's half of 2 pi? What's half of 2 pi?
Pi.
Nope, half of 2 pi is,
Pi?
what is pi over 2 divided by 2?
Pi.
Pi. Halfway around is pi.
And then up there,
So which means 180 degrees is the same thing as pi radians.
and then
So hold on. So we use the equation. Arc length is just the ratio. Radius is the ratio between arc length and radius. We knew if we went all the way around the circle, the circumference would be 2 pi r. So if I take the arc length going all the way around the circle, 2 pi r, divided by the radius r, I get 2 pi radians to go all the way around. If I only go half of that, I'm going half of 2 pi. 2 pi divided by 2 is just pi. So halfway around is pi. What's halfway between 0 and pi?
1 over pi. Like
Pi over 2.
So that's 9.
So this is pi over 2. And so I go 0, 1/2 pi, 1 pi. What's the next thing down here?
Pi.
1.5 pi, also known as 3 pi over 2. So if I would summarize this on my XY chart, I have 0 degrees, 90 degrees, 180 degrees, 270 degrees. This is definitely something I would write down. So here's 0 pi, pi over 2, pi, 3 pi over 2. And once I'm back at 0, guess what? This is the same thing as 360 degrees or 2 pi radians. This is like your conversion. Okay, so this just summarizes exactly what I did. So we know 360 degrees is the same thing as 2 pi radians, which means 180 is the same thing as 180 degrees, same thing as pi. Pi radians. So if I want to convert from degrees to radians, my hint is use the fact that 180 equals pi. If I want to convert from degrees to radians, how would I do this? Do I have a conversion factor? Do I have something so I can multiply by 1, get rid of the degrees, be left with radians? Ari?
Yeah, 180 because pi is 180.
So I'm going to use pi radians divided by 180 degrees.
Yeah.
Because this is secretly the same thing as multiplying by 1. We just talked about how pi radians is the same thing as saying 180 degrees. So if that's the same thing, I'm multiplying by 1, right? Carson, multiplying by 1. Okay, you see the quotation marks? Multiplying by 1. Okay. It's kind of like if I wanted to convert 5 feet into inches, I multiply by 12 inches over 1 foot. I cancel out feet, I'm left with inches. Conversion factor. So that's what we're going to do here, is do a conversion factor. We're converting from degrees to radians. So I have 30 degrees times pi over 180 degrees. Degrees cancels out. What's a common factor? What's something else like? How can I reduce this fraction?
Yeah.
Divide by 10?
Yeah, sure. 3 over 18. But then you can
3 pi over 18. How can I further reduce this?
6.
So 1 6.
Pi over 6. If you're doing trig and advanced algebra next year, you will know this conversion by heart. 30 degrees is pi over 6.
Oh, that's good. I'm really Wait, what?
So I was just...
I don't understand. So on the other like a radian is like just like this, but the arc.
So a
one
radian,
sector-
literally 1 radian is the measure of an angle, where the arc length is the length of a radius. That's 1 radian. So if I have an arc length that's 2 times the radius length, that would be an angle of 2 radians.
So when this arc is the same length as that.
That radius, yep.
Or,
So if you have an angle
this
measure,
angle
would be
is
1
a
radian.
radian.
Yep.
Okay.
And the pi is on the top.
The pi goes on top. Let's do B. So I have 135, and I need to convert into radians.
Is it 135 pi over 180?
So it's 135 degrees times pi over 180. So it will be 135 degrees times pi over 180. So the degrees will cancel out. What's a common factor. How can I reduce this fraction? Well, it goes into 135 and 180.
3, if you simplify the 3 and 4.
How do you know? What number did you use?
5.
Huh? Use 5? 25? 45. Well, let's make sure everyone else is groovy with this. So what if I divide by 5? Divide by 5, so let's see, 135, divide by 5. 25? 25 pi over, let's see, 180, divide by 5. 36. No, I did that wrong.
27 on top.
Huh? 27?
Yeah.
Oh yeah, because this is 35, so 7.
So do 5.
Okay. So I can further simplify this. What number goes into 27 and 36? 9. So I have 3 pi over 4.
And that's it, that's the answer.
Yep, I boxed it. That's the answer. I cannot simplify this anymore. This is how many radians 135 degrees is.
Wait, I have a question.
Yep.
So if you multiply one side by pi over 180, it's essentially multiplying by 1, so you just
Yeah,
cancel
so
out
not
the
actually changing
180
anything.
and the pi is just there.
So I didn't cancel out the 180. I'm simplifying.
Oh, okay.
I cancel out the degree. So I take 240 degrees times pi over 180 degrees. The degrees cancel out. I'm left with 240 pi over 180. Is there a... How can I simplify this? Maybe they both are divisible by 10. I'm ending with the 0. They're both divisible by 10.
20.
240 divided by 10 is 24 pi over 18. Can I further simplify?
You can do 2 real quick. So it would be 12 and 9, and then divide by 3, so it would be 4 and 3.
Good. Solid. And if I do the next one, so negative 270, once again, I'm trying to go from degree to radian. So I'm going to multiply by pi over 180 degrees. Negative 270 pi over 180. So degrees cancel out. They're both divisible by 10, so negative 27 pi over 18. So I divide by 10 first, and now what number can I simplify with?
9.
9. So this is going to be negative 3 pi over 2. So I want you guys to try E and F, try the next 4 problems, and then I will do them on the board for you to check. Try the next 4 problems. So try the next 4. I'll give you about 20 more seconds to try this out. And then we'll see if we have any questions. No. Yeah. You see how much we just did in a minute? Perfect. All right. Yes, I'm having you guys try it, and when you're done, you will check your answers on the board to ask any questions that you have. So we did some together, and now you try it by yourself, check the answers. The gradual release allows you to go home, and then you'll do it yourself with no answers to check upon.
There's a worksheet for this one.
You do. You'll get it tomorrow. All right, so do we have any last questions on these? Did we try them already? Cool, so I assume most people are done. All right, so the next part is asking about, we just did a bunch of degree to radian, so now we're gonna go radian to degree. So we just saw to go from degree to radian, you multiply by pi over 180 every time. How would you do radian to degree? Let's see, so I have to multiply, divide, so you multiply by 180 over pi. So when you multiply by 180 degrees over pi,
The pies cancel out.
the pi's will cancel out. So I have negative 360 degrees over 3 because the pi's cancel out.
And that's simple.
And I can simplify that to negative 120 degrees. Okay. So if you're like grooving with this, you can go on and try B, C, and D, but I'm going to go through B as well. So I'm going from radian to degree, meaning I need to have the degree on top and whatever radian, the pi on bottom. That way pi will cancel out. So I'm left with 7 times 180 all over 6. And the reason I left it that way is so I can simplify 6. 6 goes into 18 3 times, so it goes into 180 30 times. 7 times 3 is 21, so 7 times 30 is 210. Also, you'll have a calculator, so you can just do 7 times 180 all over 6. But you must be careful when you are doing stuff into radian and from degree into radian, because I'm expecting your answer to have the word pi in it, to have actual pi in it. So we're going to do C and D, and then so we do have a minute left. So we're going to do 180 over pi, multiplied by 180 over pi. Pi's go away. 11 times 180 all over 4. So this would be 495 degrees. And lastly, negative pi over 2 multiplied by 180 degrees over pi. You're left with negative 180 degrees over 2, which is negative 90 degrees. So we'll pick up where we left off tomorrow.